Alright, problem number 13. We got secant x minus 2 equals 0. Very similar to number 12. What we'll have to do is add 2 to the other side, so secant x equals 2. If you take the reciprocal of both sides, you get cosine x equals a half. And there are just 2 spots between 0 and 2 pi where cosine x equals a half. Those two angles are at pi over 3. And this angle way down here. And that angle turns out to be 5 pi over 3. And those are our only two answers. On to number 14. We got cosine squared x equals 4. There are actually a couple ways to do this problem. Well, I may do them both just for fun. So the way that most people do this, I think, looking at it, is they just take the square root of both sides, which would give you cosine x equals, and here's the part that most people miss, plus or minus 2. So if you take square root of both sides, remember that you need to get a plus or minus answer. You need to get two different possibilities. And now if we take the reciprocal of both sides, we're going to have sine of x is equal to plus or minus a half. So where does that occur? Well, sine of x equals a positive a half when you get these short little triangles here that are 30 degrees. That would be at pi over 6 and 5 pi over 6. Now we also need it to be equal to negative a half, and that'll happen at these triangles on the other side. So we get the full bow tie down at 7 pi over 6, that's a pi, and 11 pi over 6. So those would be the four answers within 0 and 2 pi. Now there's another way to do this that some of you may like, so I'll show you. If you were to subtract 4 to the other side, you would get cosecant squared x minus 4 equals 0. And some of you might remember from Algebra 2 this idea of a difference of two square numbers. So 4 is 2 squared, cosecant squared x is cosine x being squared. So maybe you remember that you could factor it like this. Maybe this rings a bell. And then you could ZPP and you'll get the exact same answer. So you didn't have to do that problem by that technique, but just in case you were interested. All right, let's go on to number 15. So we got 3 sine x equals sine x minus root 3. Seems like a good idea to get all the like terms on the same side. So I would subtract sine x from both sides and get 2 sine x equals negative root 3. At which point you could divide both sides by 2 and get sine x equals negative root 3 over 2. Now, where does this happen on the unit circle? Well, sine x equals root 3 over 2 when you have a tall triangle. So that will be one of the pi over 3 angles. But it has to be down here in the 4th quadrant or the 3rd quadrant because the answer is negative. So that would mean we could be at 5 pi over 3 or at 4 pi over 3. There are two answers, 4 pi over 3 or 5 pi over 3, and those are the only answers to this problem. Okay, one more problem for this video. Let's go to problem 16. All right, so we got 3 cosine x minus 1 equals 5 cosine x. Looks again like this is a problem we could solve just by doing undo operations. So I'm going to subtract 3 cosine x to the right side, giving us negative 1 equals 2 cosine x. And then if we divide both sides by 2, we've got cosine x equals negative 1/2. Now, where does cosine x equal negative 1/2? These are when we're going to have tall triangles, so the x component is very small. And they need to be in the quadrants where the cosine is negative or the x is negative. So that's quadrants 2 or 3. So our answers would be 2 pi over 3 and 4 pi over 3. And those are our only two answers. And that's the end of that video.